Hi all, welcome to the Business Analysis Training Program. In the previous session, we have seen details pertaining to user story, how user stories are created, what is persona, what do you mean by acceptance criteria for a user story, how user story is created in Excel and how is it created using a system, an in-house system in a software company. I've shown you an example for that. And then we have also seen what is the difference between process mapping and data mapping. What are the various stages in process mapping? How data mapping is related to data dictionary. Excel table design, we have already seen it. Organizational chart, I've shown you how to create a belt chart, when to use the organizational chart, and we have also seen what is a notch chart, very much similar to a belt chart, but the appearance of each of the shapes will be different. And then we have gone through the functional and non-functional requirements document, how to create a functional requirement, how to give an ID to each of the functional requirement, how do you reference a business requirement ID and a use case ID to a functional requirement ID or to a functional requirement of a system, each of the functional requirements. Then we have seen non-functional requirements in detail. And then we've seen what is a RACI matrix, how RACI matrix is created. I've shown you an example of how you can use the Excel template to create a RACI matrix, how to create the events and the actors, and how do you create the role that each of the actor plays in the corresponding event. How do you mark RACI for each and every event against the actors in a matrix format? You'll have to either create the RACI matrix in Excel or in Word document. So I've shown you the samples of Word document, which is very much similar to the Excel documents. Excel document, I mean. Okay, today we have to see very important topics. So some of those include state mission diagram. So we'll see the diagram at a later stage today. So to start with, we will cover the use case specification, requirement traceability matrix, and then we will move on to database related topics. So what is a schema, relationship and data model, Chen's diagram, and then we will see about 5 eyes and fishbone analysis. So 5 eye and fishbone analysis or Ishikawa is a part of Six Sigma practice as well. So if you work with a process improvement group, you will get to work on the Ishikawa or fishbone diagram and 5 eyes. Okay, so we have already seen what is a use case model. So use case model comprises of use case scenario and use case diagram. So in this sample, we had clearly seen how to create a use case scenario. Within the use case scenario, you have the use case scenario number, the title for the use case scenario, then most important standard descriptions that you have to follow in the use case scenario, and how do you fill in the description. You have to give a caption. We have already seen in yesterday's session how to create a Word document. We have seen all the concepts relating to creating a Word document, relating to the type of documents that we're seeing. As a business analyst, you must need all those word skills. So please go through the video again and practice it. Next level, we have seen how to convert a use case scenario into a use case diagram. So this is a simple diagram. So for this, we have used visual paradigm because that's much easier. You can also use Visio to create the use case diagram, which we have already seen. And then this is a complex use case diagram. So here we have a use case specification. So how do you create a use case specification? A use case model is nothing but creating the required artifacts, the use case scenario and the use case diagram, but then you have to document it. Either the use case scenario or the use case diagram that you create can go into the business requirement document or functional requirement document, or it can also be into your SRS, software requirement specification. So there is no restriction that you have to use a use case model, that is a use case scenario and a use case diagram only in a functional document or in your SRS document. Okay, so you can also use it in BRD. I've tried using it in BRD and it is much accepted. There's no issue with it. At times when you're working on bigger projects, they may ask you to create a separate use case specification. So for example, while we were going through the functional and non-functional requirement document yesterday, we have seen that there is a place where you have to reference the business requirement number or ID and the use case ID. So that's when you have to create the use case specification. So in a use case specification document, you will only have use cases defined. Okay, so this is an additional document other than your BRD, and functional and non-functional specification document, and then your SRS. So other than BRD, functional and non-functional specification document, SRS, you also have something called as the use case specification. A functional and non-functional requirement document can also be a FRD. In short, they can also refer it to as a functional requirement document. A functional requirement document includes both functional and non-functional requirements. So in a use case specification document, you'll have the project name. So you can either have this as a cover page and you can move this down from approval and distribution list. You can move it down and you can have it on the second page, or as you wish. This is the standard style of template that we were using. So I've given you the same. If they say you should not have approval and distribution list, etc. on the cover page, you can create a new cover page to it. You know how to add, insert, add a cover page. Okay. So here it is a direct project name, approval, who are all the stakeholders involved in the project, their approval, approved or not, sign, their signature, their job role, and the date. Distribution list, to whom you're going to distribute this, the name and their position. Within the name, you can also have their email ID. One step down, you enter their name, then press enter, and then their email ID and what is the position that they hold. Author, that's you, business analyst, what is the version of the document, and then the date when it is created. Use case specification should be the header with the project name. Version control, what is the version of the document, author, title, email ID, date, etc. So these we have already seen. Document details and related documents. So the first part of the document looks very much similar to the functional document which we have already seen. And then what are the contents of a use case specification document? So here, insert the feature name. Example, exam session. What is the name? What is the feature or the functionality for which you're creating the use case? So here, if exam session is the feature name or the use case for which you are creating the use case model. So here, creation of trading season is the heading. So what is the title or the description for what you're going to create a use case? Use case model or the activity diagram, you can have both defined. Provide a use case model showing the use case and actor, or you may provide an overview of the steps, making it big, overview of the steps of the use case in an activity diagram. You may provide both if you wish. So my suggestion is provide both. So here's the use case. So enter the name. So here you have to write it as use case scenario 1, creation of trading season. So that's what you have to define here in the heading. Give a use case number. So that's UC01. Primary actors. Who are the primary actors? So whatever you have defined here in a use case scenario, if you're creating a specification, if you're just creating a use case scenario and a use case diagram, you can create it in the same pattern. However, I've given you here, you can take the same example and you can put it on your other documents, BRD, FRD or SRS documents. If you're creating a use case specification document, then use this Word document and convert all these, whatever you have typed here, you will have to move it into these rows of your table. So this is in a table form in Word. So we all know how to create a table by now. who are the primary actors involved. For example, it could be a web administrator. So here, who's a primary actor? He's a system administrator. Are there any secondary actors involved? What are the triggers? So identify the event that initiates the use case. This can be an optional entry. If you do not have any triggers that you want to enter, then you can ignore the trigger part of it. Then you have to enter the precondition and post conditions. So preconditions, prior to starting off with this use case, what are all the conditions that must be satisfied? A precondition can also be referred to as an assumption. Means all the required features are already available in the system. User has read and understood the system functionality and valid till date is entered prior to creating the trading season. All the pre-system conditions should be met before you start off with the use case. So that's referred to as a post condition. At times you can also add it on to the assumption. But if you're having any other system assumptions that is different from the precondition, then my suggestion would be to keep preconditions different from assumptions. Post condition, so we already have it here. What is a post condition? So after trading season will be valid till valid date as defined in the trading season page, and the trading season gets created. Supposing user enters all the details and then clicks on the save button. So when user clicks on the save button, automatically the save activity should take place, which means the data, whatever the data has been entered for a trading season, should be accepted by the system and the trading season should get created. So that's what is referred to as a post condition. After clicking on the save button, what should happen? Or after clicking on, if there is an alternate flow, which means if there is a cancel button, what will happen when the user clicks on the cancel button? So that's what is described here. In the alternate flows, you have to describe it. Normal flow. So a normal flow is nothing but the basic flow of the entire activity. So here we have a very simple activity. Actor logs in with the correct credentials, opens the create trading season page, enters all the information and clicks the save button. So the same thing you have to describe here in the use case, what the user is going to do with the system. If there are any exceptions, you can enter the exceptions. Includes, so you know what are includes, right? If you are splitting your use case, so we have already seen what is an include. So you have to describe include. If you have any include and extend, you have to describe here. Okay. If there is an include, what do you mean by an include? Withdrawing money from the ATM or the actor wants to change the phone number, the entire activity is split into another activity where the customer authentication should take place. So while writing the specification, we haven't created a user scenario for this, right? The user scenario is for this diagram. So for this diagram, when you create a user scenario, you will have to describe what is the dependency, what do you mean by includes, what is extend, and what is the general activity. So you will have additional standard definitions added to the use case scenario, and you have to describe what you're trying to do in the diagram. So here you have to give an explanation for includes. So what will you say? If the actor has to withdraw money or the actor has to change the phone number, there has to be a customer authentication. Customer authentication is a split use case. So here multiple use cases can be split out into separate use cases that is included by one that need that common functionality. That is withdrawing money or changing the phone number requires customer authentication. So customer authentication is a separate use case which is included to the money withdrawal or the phone number change use case. So that you have to describe under includes. And then special requirements. If there are any additional requirements such as non-functional requirement, because most of the time in a use case you will be describing the functional requirement. Within a function of a system, what are the various steps followed? So that's what you will be describing, right? If there are any special non-functional requirement that you would like to specify, you can specify that under special requirements. Assumptions I've already told you. If there are any system alerts, you have to create alerts. So I have used alerts in the scenario. So alerts can also be included. And then notes and issues. So alerts are nothing but notes. So if you have any special notes, you can specify the note, or if there are any system issues. Alerts include a success alert, a failure alert, any system issues, anything that you can mention under notes, issues and alerts. Okay, so other than the standard definitions that we have seen under use case scenario, you must know where trigger is used, what is a precondition. A normal flow is also referred to as a basic flow. And then when do you add includes, extend, generalization and dependency. So diagrammatically, you know what is the meaning of a dependency, what's include, what's extend, and what is a general activity. So how will you describe extend? Extend is an extension of the use case. So receipt printout is an activity. To that activity you have, that is an event, to that event you have an extension wherein some help is needed in getting a printout of the receipt. So how that help is defined? That help is defined by extending the receipt printout help use case, and then to that extension you have an extension point wherein you will describe what is the kind of a help that the user will get by using the help option in the system, right? So all those details, whatever you describe in the diagram, should be added to the use case scenario in the Word document. In general, they can also refer it to as a use case. A use case or a use case scenario means the same. Use case diagram is referred to as a use case diagram. There's no other definition to it. The use case and the use case diagram together is referred to as a use case model. So this is an example. So you will describe each and every use case one below the other like this. So in this use case specification document, you will have details only about the use case. So this is for one complete functionality. Say in a hospital management system, if your use case is for all patient activities, right? So all patient activities can include n number of activities that a patient can have in different stages as he moves through the hospital workflow. So you will capture all the use cases relating to the patient activity. Patient is your actor, and all the events or the activities performed by the patient will be captured under the use cases within the main topic patient use cases. Next, you will have another new topic. So here within patient use case, you have two different use cases. Next, you have to insert a new feature name. Feature means functionality. So the next functionality could be receptionist functionality, or you can directly say patient functionality of the system. Receptionist functionality of the system, that is also correct. So within receptionist functionality, what are the various activities that a receptionist can do? So you will describe each and every, you will first split the activities performed by a patient or a receptionist. So here, if it is all about receptionist, you will capture all use cases about a receptionist. So what are all the activities that a receptionist can do, and how you can divide each of the activity into a use case. So each and every activity that a receptionist does with the system should be grouped together, and you have to separate it into different use cases. So here you have multiple use cases for receptionist. Similarly, you will have one other features. So if it is for HR management system, you'll have one complete use case for recruitment. So you will type it as recruitment functionality. So within recruitment functionality, there can be so many use cases that you have to write based on the system business requirement that you've got for the recruitment process. So you have to split the use case for each and every sub-module within the recruitment functionality and create the use case for it. And then if you have any additional terms that you have used, jargons, technology-based phrases, etc., then you have to, or domain-specific terms, you have to define it in the appendix and tell the user that you've used these terms and this is what it means. Okay. Generally, if the user doesn't understand any of the terms, a little complex ones, they'll move to the appendix and see them if it is available in the appendix. So that's what is defined here. So if you see here, first you have the feature, that is the functionality of the system. Again, within that you have the use case model and the activity diagram, and then you have the complete use case defined. Then next, for the next feature, you have same, the use case model or the activity diagram. Use case model is your use case diagram. So a use case model or the activity diagram and both, and then you have defined the use cases for it. So here you see activity diagram is not just specific to, where did we see the activity diagram? We have seen it in the system design of the ASAP project. It is not very specific to a system design. So while you're creating a use case specification, that can be used, referenced in a BRD or in a FRD or SRS, you can use the activity diagram. So whatever diagrams you've learned, don't think it should be used only in a system design document, etc. So wherever you have an activity that you want to represent, you can use the activity diagram. Wherever you have a sequence of activities to be represented, you can use a sequence diagram. Done. So we're done with the use case specification. Now let's move on to the next topic. Very important. For sure, you have to create a use case specification in whichever project you work. Requirement traceability matrix, another very important topic. So here is a sample traceability matrix. So how is the document naming done? The project name, traceability matrix, V is a version, and then the version number. Similarly, for use case specification, project name, use case specification, underscore V, version number. So I've already told you how to work on the version number. Just to revise, 1.0, here 1 is the major version number and 0 is the minor version number. 1.0.0, 1 is a major version number, 0 is a minor version number, and again another 0 is a minor version number. So this is what we have seen in the Word documentation yesterday. So if it is just 1, it is a heading 1. 1.0 is heading 2. 1.0.0 is heading 3, and so on. Draft version, a version that is ready for approval. HR management system, V 1.0.0 refers to the very first version of the document, or it is a draft version. And then how do you increment the version numbers? It can either be version 1.0.1 or version 1.1.0. If there are any major changes made to version 1.0.0, then it becomes version 1.1.0. Otherwise, it will get changed to version 1.0.1. For minor changes, increment the third level number. For major changes, increment the second level number. And then on, if there are any small changes, after changing the second level number, you will again increment only the third level number. So it becomes version 1.1.1. If there is if there is a functional change that you have made to the document, it's a minor change. It's not a complete major change. It is only a functional addition to it. So you will change the last number, that is version, that is the third number. It becomes version 1.1.2. If there is a new requirement added, then that you will change the second level number, which is 1.2.0. So this is how the version numbering is basically done. So be it, you know how to do it within the Word document, how to increment each of the headings, but for a document, this is how you have to increase or increment the version numbers. Now we will move on to the requirement traceability matrix. So if you see here, in the first page, this is a standard template for RTF. You can directly use this template. Requirement traceability matrix. As the name says, it is a requirement. Traceability means tracing in a matrix form. Basically, you are creating a matrix that can help you trace the requirements. So what are the type of requirements that you can trace? We will see that in detail. You have the project name. Click here, type the project name. HRMS version 1.0.1 hyphen. Okay, so this is how it has to be. And then who's the author? Author is my name. What is the version of the this document? RTM. In short, it is referred to as RTM. Okay, this is version 1.0. I do not want to have bigger versions. And then what is the date? You'll have today's date. And then you have to have the version control done. What is the version number? Name, title, date and comments. So whose name? Who's going to review this document? So who's going to review this document? It's me in the first place. So I'm a BA, and then 23/4/2017, and what are my comments? So for a document that I write, I can review it. For a document that I've written, I can also have another colleague of mine to review it. So Mark can also review my document. So he's a SBA, he's a senior business analyst, or he can also be a lead BA. And then when is Mark going to do this? Mark is going to do this on 25th. So our comments will be there. So my comments include initial draft of the RTM is ready for review. And then Mark will review the RTM and he will add his comments. We'll go through the document and then we will add the comment so that you will get an understanding. OC to BR. This is the first type of RTM that you will create. So what is OC and what is BR? OC, this refers to the business outcome as defined in the business case. So we have seen the business case template, how to create a business case and how to apply a business rule to a business case. What is BR? This refers to the business requirement as defined in the business requirements specification document. So here you'll have all the business outcomes defined on the top of the matrix in columns and all the business requirements defined in the rows. So here, creates exam sessions, training details are captured. So these are all the business outcomes that you basically get from a business case. So what is the business requirement corresponding to that? We have a business requirement that has been created for each of the business case outcome. So that is referred to as a BR01 1.3. That is the section in the document, a topic in the document within the BRD document. The best way is to give the business requirement number. For sure you should have a business requirement ID. A BR business requirement ID is it starts with BR. A business case starts with BC. A functional requirement starts with FR. Non-functional requirement starts with NFR. Use case starts with UC. So remember all these short terms. These are very important when you create the IDs. Okay. And you can have the business requirement ID defined, or if you do not have that, then you can have it in wording. So you say trading session handling and the business outcome of the business cases or trading details captured. So here you will put X. X means it is corresponding to this, is corresponding to this. That's why you have X here. Mostly they will not expect you to create OC to BR. The first level will be a BR to FR and the second level will be FR to TR. This is just for your understanding. This may not be required at all. This is at a very, very basic level. They may not need it. The first level that in as a business, what they will see is a business requirement. They are not bothered about the business cases or the business outcomes. So it is all referred to in the business requirement is what their understanding is. They do not want too many documents, right? So you can ignore OC to BR, but just have an understanding so that when you explain, you can explain, right? They will surely ask you about RTM. So when you talk about outcomes in a business case and then how it is linked to BR, it will show your level of understanding about the business analysis process. So that's the reason I'm giving you this example. But you can tell them out of these three within a requirement traceability matrix, there are only two main things that is followed. One is a BR to FR matrix and FR to TC. That is a test case matrix. So BR to FR, here we have the business requirement IDs. Okay, and then we have the functional requirement IDs. So we know how to create these IDs within each of the documents. So BR01, FR01, add student alumni. So if you remember in the yesterday's document, it's a functional and non-functional requirement specification document. So in this document, whatever we have seen, I've tried to put that on the RTM matrix. So for this particular requirement, FR01 with a business requirement BR01, wherein the student is added to the alumni list. What is the requirement traceability matrix? So we have a business requirement written. So in a BRD, we assume that this particular business requirement is captured, where the student is getting added to the alumni is defined as a business requirement. And then we have the FR defined for it, that is a functional requirement. So here we have a FR and we have the reference to BR and UC. UC, I've just shown you how to create the UC specification. BR, we have already seen it as a part of the BRD document, business requirement document. And FRD, this is how it is. So in a requirement traceability matrix, you will keep three documents open: BRD, FRD and use case document. So only after all these documents are created, you can create a RTM. Without these documents, you cannot create RTM. Okay. So within the RTM, no one wants to see major explanations. All they want is the IDs, which is the, business requirement ID and which is the functional requirement ID. So here for the student alumni functionality, the FR ID is FR01. And then here, what does 7 mean? The FR01 is the functional requirement ID, but within your document, don't let the user do a control F and search for FR01. If you can give the number, whatever number you have here within the square braces like this, it will really help them. Okay. So in BR01, we assume that this particular business requirement is defined under the topic 1.3. So in a business requirement document, BR01 1.3 document section or topic number, and in a functional requirement document, FR01 with a topic document topic number 7 refers to student alumni, add student alumni. See how easy it is. If you can create this sort of a matrix, it is a requirement traceability. So now you understand the meaning of the term traceability, right? So traceability means you're tracing where it is. Imagine for a bigger project, you will have one full Excel workbook containing this type of a requirement mapping. Okay. So if you do not have a proper explanation, then it will be very difficult for you to understand. So FR017 and BR04 1.6 refers to view student alumni. And then for student payment, there was one more that we have seen for student payment, right? So here's a student payment. So how is this going to be mapped? So this is FR02. Section is same, 7. Section means topic of your within your Word document. That's why I told you numbering is very important within the Word document. So now BR02 number 1.4, this is referred for a student payment. So if at all you have to look back which functionality is defined in which part of BRD, in which part of FRD, this could be the easiest way to do it. The reason we are not giving a reference to the use case is because it is already defined in the FR. So once you have a mapping of BR and FR, it's much easier to capture the use case. If you want to do it for use case, you can do it. That can be referenced to as a BR versus use case or FR versus use case. So here in FR versus use case, all your use case numbers will be defined on the rows and all your FRs, FR01, 02, etc. will be on the columns. It is up to you. How you want to create the matrix is up to you. But keep it in a traceability matrix format. So it is a requirement traceability matrix. You're tracing the requirement. Where is it created in a BRD document? Where is it created in a FRD document? Where is it created in a use case document? That's what you're doing here. Give an explanation what is for BR and FR. If you're using UC, describe what is UC. Next, FR versus TC. So we will see in detail what is a test case, how test cases and test scenarios are written. For example, we have a test case 01. That's the test case ID. Similar to your use case, this is a test case. Whatever is your use case, whatever is the functionality you've created, you have to check that. How do you test? Checking means testing. How is the testing done? A test case is written for it. That is created with an ID, which is called the test case ID. That is TC01, a test case heading, that is add student ID to alumni list. And this is within the topic 1.2 in your Word document, test case Word document. We will see how to create a test case and a test scenario Word document. There is a standard template for it. We will go through it while we learn more about the STLC process in our next session. Check if the student ID exists and add as an alumni. Open the student alumni page or form. Log in as a system administrator. Login success. View the student details page. Login failure. Display an error message that the login failed. In the student page, enter the student ID in the text box. Click on the search button. On search success, display student details. On search failure, display system error message, student ID could not be found. On search success, view the student details and click on add to alumni checkbox. Click on save. Alternative 01, to reset the form, click on reset button. This should clear all the fields. Alternative 02, to cancel the student addition to alumni, click on the cancel button. After completing the process, system administrator clicks on the logout button to log out from the system. Do you see how a simple use case is converted into a test case? The use case got converted to a functional requirement, and a functional requirement got converted into a system. The developer read the functional requirement and he has created the system. So now you should get a complete understanding of how. So this was the basic functional requirement that you wrote as a business analyst. The system shall validate the student number against the university master list. If student number is not found on the list, an error message shall be displayed and the student shall not be accepted as an alumni. This is what you would have written as a business analyst describing the function of the system. But look how that description of the function of a system has been converted into an actual system. The number of steps are now more than what you've written as a functional description of the system. So here, first the student ID gets checked. Is that correct? So you say you validate the student number against the university. So that's what is happening here. A student ID existence or not is checked. Open the alumni page, then log in. So these are all the system description. In a functional description, you will not talk about open the login page, create a login page, open the login page, see for a success, click on that particular button. You will not go to the level of clicking a button or whatever it is. That goes into the system design aspect. When you create a functional design document, you can describe all of these steps, right? So at times they may ask you to create a functional design document, or they may not ask you to create a functional design document. A developer can read your functional requirement and directly create the page. Or if they ask you to create a functional design document, FDD, then within your functional design document, the design definition should contain create a login page. Within the login page, how many text boxes should be there? One for username, one for password. And then you should have a save login button, reset button, and a cancel button. So this is more system specific. As a business analyst, if you have the technical capability of understanding what is a text box, what is a button, what is a combo box, what is a radio button, what is a checkbox, list, all these are very important and forms the major part of the front end of the application. Right? So most of the time it will be taken care by the system analyst within the development team. Right? So when you have to also write a test case, but for a test case it is much easier because the system is right in front of you. You have the complete interface in front of you. So you will know what is a text box, you'll know what is a button, you will know what is a checkbox where you have to click on a checkbox, because the developer will give you the screen, as well as if you have any doubt about the functionality, then you can check with the developer on what is the name of the, those are all referred to as controls, text box, buttons, these are all controls. Okay. So this is how a test case is basically written. Now, a test case can be written by a tester or by a business analyst. A business analyst is also a manual tester. If you have coding skills, you will also become a code-based tester. So that's the difference between a black box testing. Black box testing is for functionality testing. White box testing is meant for code-based testing. So this particular document that maps FR to TC, or at times you may also have to map a use case to a test case. That is also possible. But most of the time it is a functional requirement versus test case written for that particular function. As a developer, all your functional requirements or a functional design will be read by the developer, and directly the developer will look into wireframes. If there are any, we will see how to create a sample wireframe. The developer will look into the wireframe and he'll start developing. He'll start creating the front end of the application. So there are various software technologies that are available to create the front end of the application. So that's what the developer will be using. So here, what is that we're going to do? FR01 topic 7. What is it referring to? Topic 7, functional requirement FR01. This refers to adding a student alumni. So in BR to FR, it is referred to as student alumni, add student alumni. So here it is the same, add student alumni. So you will say add student alumni. Right? Do not use X. I have seen documents that just uses X. Means it is matching. But what is matching? TC2 and FR2 are matching. Where is FR2? How will they go and search FR2? Where will they go and search TC2? Which section of the document is that? What does that actually mean? Right? So don't leave the end user who's looking into your document. A person who's going to do a quality audit on your project will mainly look into the traceability matrix, because if they have to look at a particular matrix, so if your FR7 and your TC8 describes about receive, payment, receive, semester payment. So if you don't have this description, right, you can make it look, you can zoom it lesser so that you can add more text. You can also keep it smaller because there's going to be a lot of information that you will add. That is okay. But just because the spacing is an issue, don't make it just a tick mark or X. They will not understand what it is. The auditor who's going to audit the document for giving a better CMMI level will put a negative mark on this type of documentation. If you put an X, what does it mean? How long it's going to take for them to trace back and see is FR2 matching TC2? If you directly say FR07, it is in section 3.5 of your document, and TC08 is under section 4.5 within the document. Perfect. This is what they want. This is what a traceability matrix means. Looking at something to trace back where it is actually there in the document. You should make a developer's life much easier. Right? A quality auditor's life much easier by looking at the document. Within minutes they must know, within few seconds they must know what it actually means, and they should be able to trace back that particular requirement from the various documents that you create. So this is the importance of traceability matrix. You have to create very good traceability matrix. Please use this as a sample. This is the best traceability matrix that we can ever have. If you want to keep it in a Word format, you can keep it in a Word format, but I'll tell you what is the problem with Word. When you have more number of functions, right, on your columns, when there are more number of items on your columns, if there are a lot of rows, it's okay. If the number of columns increase, it can be an issue with your Word document. Even if you set it to a landscape, it is not much clear, and they'll have to zoom it and they'll have to struggle with it, convert your Word document into multiple pages and do all type of front end, a proper viewing activities to see what it is actually. But if you're having it on an Excel file, it is much easier, right? And at times I've seen they also have this requirement traceability matrix created on Excel, and they also move it to a database. It's moved on to a table, and then they start querying the table. If that is there, whatever we're going to learn as a part of the SQL, that will help you. Okay. So we are done with requirement traceability matrix. If you have any questions about RTM, please have it to the end. I would like to answer it because it is very, very important. As a BA, this is one of the most important activities you will perform along with your documentation and modeling, diagram and modeling skills. Schema. Let's go back to our Diagsoft project. So within the Diagsoft project, we have seen what is a schema, but not in detail. We've just seen the basics of it. So we left it half the way. If you remember, in a Diagsoft project, we had stopped it with proposed system. What is the present system and what is the proposed system? So now we will move on to the technical concepts. So here we have the schema. First you have to understand what is schema, what is the data flow, and then we will move on to the Chen's representation and the relationships. Okay, so now we are getting into basic to intermediate topic about database. So that is schema, relationship in data model, Chen's diagram. So other than this, we also have concepts relating to entity relationship notation, types of relationships, and Crowfoot or ER diagram, definition of normalization. Okay, so this is an entire set of concept to be defined. This is an advanced concept, I would say, at a BA level. But if it is at a database developer level, this is a basic concept, I would say. So at a BA level, this is referred to as an advanced concept for you to create a data model. So first we will see the basic concepts, and then after Chen's diagram, I would like to leave it, move on to the other topic, and then we will get back to the entity relationship diagram at a later stage today or in the next session, because if I do it in one stretch, it will be confusing for you. First, you get to understand the basic to intermediate level of how a data modeling is done relating to database. Whatever is the concept that we are going to discuss now is all about a data modeling for a database. So we have seen what is a DFD and DFMD pertaining to the documentation and the process flow, right? So that is different from a data model that you will create for a database. So whenever they ask you to create a data model, you must be clear whether you're creating a data model for a process workflow or is that for a database. The concepts are different. Now we will start with schema. Schema is very easy to understand. Here is a sample schema. How do you create a schema? You have to create a schema using Excel. Or you can also create it using Word. Both are fine. So how is a schema created? You have to first identify what are the entities in your system. Each of the functions in a swim lane diagram that you create, it can be a cross-functional swim lane or activity swim lane. Somewhere you will define what are the different functionalities of your system or different functions of your system. So each of the function is referred to as an entity. all the sub-functions within the main function is defined in a swim lane diagram, which we have already seen. So in a hospital management system, in the sample swim lane, we have seen what is an entity, what are the different functions that we can add. We have added patient, receptionist, doctor, lab, right? Though we didn't define doctor, lab, etc., we defined the activities performed within the patient and the receptionist functionality. So a patient is an entity. Now your technology, the jargons that you use will change. When you're talking about a system design, you will call it a function. When you're talking about a database design, you'll call it an entity. Your main functionality of a system is your entity. Who are the actors? Who's the main actor of that functionality is called as an entity. It is not just the human entity. It can also be a system entity, which we have seen in the sequence diagram. So what did we see in the sequence diagram? In the sequence diagram, we have seen the user sending a request to the software application. Software application sends that request to the database. From database, it comes back to the system, and then system to the user. So these are the sequence of events that we have seen between the various actors involved in a sequence diagram. So here, patient is an entity. So within the patient entity, what are all the various attributes? Means description of a patient. How do you describe a patient? We describe a patient with a patient's name, age, gender, address, reference doctor, reference hospital name, consulting date, and a patient ID. All the information relating to a patient that sits within the patient entity is referred to as an attribute. Please remember this, irrespective of whichever domain you work, you have to identify the entities and the attributes. So once you're done with all the process steps that we have followed in these many classes, so whatever we have learned so far, it is all process based, or it is more domain specific, and it is process workflow definition within each of the documents that you create. Whereas in database, you will talk more about how you identify an actor within the main functionality of the system. How many functions have you divided your system into? So each of the functions you will capture the entity. What is the entity? And then for each of the entity, you will have the description for that entity. So the description for an entity is referred to as an attribute. So here we have other samples. We've seen patient, history. History of the patient includes history ID, history date, and the patient ID. It is linked. Test. The patient has to undergo some test. So that includes test ID, test name, department number, test charge, and the reference charge. Staff. One who's going to perform the test. Test means lab test. It's a blood test or whatever test. Staff ID, staff name, age, gender, qualification, job, designation, department number. So within department, you have department number, department name. Within bill, you have bill number, bill date, report number, report date, patient ID and amount. Test result, you have the patient ID. What is the result and what is the impression? Impression means what is the outcome? Is the patient having some problem within the blood test? If the hemoglobin count is less, if the WBC count is varying, what is the impression, right? So you have to create a schema even before you start off with the relationship. So after you create a schema, either in Word or Excel like this, then you have to understand what is the relationship. So here is the sample diagram that defines a relationship. What are the different types of relationship? One-to-one relationship, one-to-many relationship. I think I should have a document for this. Okay, so we'll see with this. One-to-one relationship, one-to-many relationship, one-to-one relationship. It's called one-to-many relationship. Many-to-many relationship. And many-to-one relationship. So one-to-one relationship means one college can have only one dean. Head of the college can be only one. For one college, there can be only one head of the college. So that is a relationship of one-to-one between a dean entity and a college entity. So as I told you, patient is a human entity. College, dean is a human entity, but college is it's a place entity. So it can be a place entity, process entity, sales, order. So all these are process entities. Department within a college. So these are all place entities, right? College is an entity. It is a building. It's a place where students go to study. University is an entity. Professor is an entity. Course is an entity, right? So dean versus college is a one-to-one relationship. Next, what is one-to-many relationship? One university can have n colleges. Don't worry about 1m etc. Simple language, when you put it in simple terms, one college can have only one dean. Simple logic. One university can have many colleges. M means many. That's it. One university can have many colleges. Is that correct? Yes, it is correct. M to M relationship, that is many to many relationship. So where do we have an example here? Okay, one example for a M to M can be many patients undergo many tests. You can have many patients undergo many tests in a lab. So that is a M to M relationship. Next, many to one relationship. Your source is many, but the destination is one. So what could be a good example for that? Many patients can undergo one test. Hemoglobin count is one test type. Many patients within a day can undergo a hemoglobin count test. So that becomes a many to one relationship. So if you see here, one university has many colleges. One college has many departments. One department has many students. So these are all attributes of the students. Many students register to many sections. One department has many courses. One course has many sections. Sections, one professor teaches many sections. Many students register to many sections. So between a professor, many professor has one department. So within one department, the flow is from within one department has many professors. Okay, one department chair has one professor. One professor teaches many sections. So this is the kind of a flow that you have to create. So within the data that you're going to analyze, you have to capture all the entities. Forget about the attributes for now. When you're defining the relationship between the entities, you have to first capture all the entities within your data. So what are the sample entities here? University, college, department, course, dean, patient, test that the patient has to undergo. So within sales process, what do we have? We have sales, order. There are many processes. So if you see here, this is another ER diagram. So end of the Chen's diagram, we have to create an ER diagram. So the basic for creating a Chen's diagram is first to understand what entities are and then how the entities are related, and then you have to define the attributes of the entities and create a Chen's diagram. So this is a sample sales process. So here customer is an entity. Customer place orders. Within orders you have order details. Order details are linked to products. Products are linked to suppliers. Products are also linked to categories. Customers are linked to customer demographics, where the customer is from. And then orders include shipper's detail because you have to ship the order. And then who's going to work on the sales process, the order completion process. So orders include employees who's going to work on the orders. Then again, employees contain employee territories. So within employee territories, you have a common territory table where employee table is linked to the territory table, and then territories are linked to region. So this is a complete normalized form of the entire sales process. Customer places an order. The order is processed by the employee, and then the suppliers are contacted. Suppliers are given the order details. Suppliers then supply the products to the customers using shipping. So shipment details are also captured. So this is the actual explanation, domain-wise explanation. So this is nothing but the supply chain management, right? Orders are placed and it is processed and delivered. You can take an example of an online purchase. So in the user story, we had an example of an online purchase being placed. So how it will get processed in the backend, this is how it has to get processed. Right, so we will see this in detail, why there is a key symbol, what does this mean, right? There are several relationship diagram notations that you've learned as a part of your Crowfoot or ER diagram, which we will see in detail. But for now, try to get to understand what is a relationship and how do you identify the entities. So I've shown you three different types of domains. One is a supply chain domain, in which customer, order details, products, suppliers, categories, employees, these are all entities. Within patient, we have seen that patient, history of the patient, test undergone, staff performing the test, department, these are all the entities. Another simple diagram in which we have a description of university versus college. One university has many colleges, one dean has one college, and then one college has many departments. So here we are defining the relationship between the various entities within a university to college domain. It's an education domain. So this is how you have to create a diagram. So we have seen what is a schema, and we have seen what is a relationship in data models. Next we have to see Chen's diagram. So now we have this understanding, so we'll quickly finish the Chen's diagram, which will be much easier for you to understand now. So I think all these diagrams are covered for you, all right? This has to be done. This should be done. Oh, mind map is missed. Okay. These are all done. 1, 2. Okay, we have only a few diagrams to finish off. We'll finish it. Right, so here is a sample Chen's diagram. First you understand the Chen's diagram. Then I will show you how to create a Crowfoot diagram, and within the Crowfoot diagram how you can embed the Chen's diagram. So a Chen's diagram should be added within a Crowfoot. So first you create the Chen's diagram, then you will create a Crowfoot diagram and then have the Chen's diagram within it. So don't get confused, this is a little advanced, we can do it later. First understand the Chen's diagram, very, very important topic. Open Visio. So now you know how to create, identify entity, how to define the relationship, and how to create a schema in Excel or in Word. So before you create Chen's diagram, your schema must be ready. Go to Shapes, click on Software, Database, Chen's database notation, the first one. That's all. You don't need any other diagrams here. All you need is the shapes that are a part of the Chen's diagram. Now, all the entities are defined using entity. A relationship is defined using a diamond sign. Decision is different from a relationship. Attribute, description is defined using this oval. A relationship connector, you can either use this or you can use the connector. Very, very simple, only 4 shapes. They will ask you what is Chen's notation, what are the different types of database notations. You have to tell there's a Chen's notation, crowfoot notation for creating ER diagrams, and UML database notation. Primarily, we will work with Chen's notation and crowfoot notation. So within Chen's notation, what are the various shapes? This will be another question. Then you have to describe what is a schema. Within a schema, what is an entity and what are attributes, and what are the different types of relationships. So what are the types of relationships? So these are the types of relationships. I will save this file on the blog. Okay. Back to Visio. First, create the patient entity. Drag the entity. Reduce the size of it. Don't keep it too tiny. Let it be legible. Patient. So now you have defined the entity. So what are all the attributes of this patient? Click the attribute and place it above. So once you do that, you can drag it and automatically this will move out. Reduce the size as per the need, and then however you want to rotate it and wherever you want to place it. Okay, here you find that small yellow square. You can use that to move the line. Okay, the first one is a patient ID, PID. If you think this is too big, you can reduce the size of it and make it smaller. Okay, you can reduce the height of it as well using the small yellow square. Use the space key. Right, so this is ready. Now next attribute, drag it and drop it. Patient name, P name. Reduce the size of it. The way you design the diagram is a little different here. So you have to be thorough with how do you use the options within a shape. So within a shape you have a rotate here and you have the yellow small square that you can use for moving this line. Okay. Now use this shift key and drag it down. Keep it even. You can rotate it as per the need. Okay, this looks good. Next, age. Here you can also copy paste the previous one, so you don't have to adjust the size. Just keep it like this. Move the space. The yellow small square that I'm referring to, see, you can find it here. When you click, both the top oval part and the line Both are selected. Drag, keep your pointer here on the yellow line. Yellow square, I mean, that's sitting on the line. So you have to find the 4 arrow mark and then place it on the yellow square, small yellow square, drag it and move it wherever you want to place it on the entity. Keep it as close as possible, give some proper spacing. You have to keep it neat. Most of the time Chen's diagram will look clumsy, that which they won't like. So if you think your diagram has to be increased in height, you can use a shift and a up, right or top bottom arrow that you have in the keyboard to adjust the, yeah, now it looks fine. So you will get this only by practice. You must know dragging a shape is much easier, attribute a shape is easier, but how do you fit that properly on an entity matters a lot, because there can be so many attributes that you have to define, correct? And you can have it completely, okay? You can use all the edges of your entity to define all the attributes, but don't define an attribute above another attribute. For example, this is incorrect. Don't do this. Okay, we are not creating a data warehouse or a dimension. So here we cannot have a snowflake schema. In data warehouse, we have concept called star schema and snowflake schema. If you're doing something like this becomes a snowflake schema. One dimension has an explanation of another dimension. So this is totally incorrect. You are going away from your normalization concept of RDBMS and you're hitting your data warehouse concept. Absolutely incorrect. So never try this. Don't ever do this. If you don't have a space for the attribute, please try to adjust it as much as possible. For example, if you want a copy of this, you can copy it and then drag it over here. You can keep it something like this. Use a shift and a arrow key to reduce and increase the height of it. I'm reducing the height to match the previous height. So this is what I want. So I can have one more. So now this should be inverted. First change the direction. Keep it away. Let me do this again. How do you create a new attribute that can be added below? Copy, paste it, move it to a spacious area and then rotate it. Right? Now you have to change the text direction. Go to position and then can change the can try these. Okay, this is the correct one. All the required rotations will be either within rotate shapes or rotate diagram. So for shapes you have to use the shape. Now I have used the horizontal rotation. Use this, move it correctly. Use your shift key to reduce the height of it. Match it with the top one and then move it to a proper corner. Rotate. So you can give a name to it. So this could be the patient age, PH. Okay, so similarly you can have all the, if you want this text to be rotated differently, you can try that. So you'll only rotate like this. Okay, reduce the height of it as needed. So this could take some time for you to get hands-on, practice and do it. But still, I would suggest this is a very important diagram and you have to practice this. So next, what is the level that we are going to define here? Patient undergoes test. So you have to define the test entity. So already you have, it is a one-time effort. So once you create for one, you can copy paste. That is the best part of Visio. So if you don't want, select that and hit enter, delete. That will delete it. So this is the test entity. So within the test entity, we have the test ID, test name, test cost. Now we have to link the patient to the test. So let me move this. Okay, automatically when I moved it from here to here, it is changing its position. Now I can use a shift key and I can make it bigger. So you can try one more like this. So when you place it somewhere, you can add as many attributes. That's what I'm trying to say. So now we will try to add the relationship. How is a relationship added? You need a relationship. So what is the definition of the relationship? Patient undergoes. Undergoes. Reduce the size. You can always keep it at 8 or 9. That's more than enough for a relationship. It can even be smaller. That is also fine. And then it's too tiny. You have to define the relationship. So here, take the relationship connector. Automatically it connects to the relationship. Right click. You have different options. Set begin optional, set end optional. So here what we have done, we have selected set begin optional. If you want to define the relationship, you can do it this way, but my preferred way of doing it is one patient can undergo M type of tests. So we are defining the end. So if you see here, it is the end. It's a style. Okay, so now this is a two entity based Chen's diagram where we have a patient entity defined and a test defined. So these two are entities. There are attributes for patient. You can have more number of attributes filled in here and more attributes filled in a flower format. So when you have a lot of attributes defined in a proper height and same oval size, it gives a flower format. Most of the time you can even create a circular flower format. It will be a circular flower format of all the attributes surrounding the entity. That will look very nice. Next, we have the billing. So I've already done this, so I do not want to redo this. I will take this as is. So I'm taking the billing entity. I'm placing it below the test. And now there should be a relationship between patient and billing. Is test being related to billing? No. A patient is getting billed. So patient and billing should have a relationship. So patient amount charged, that is shown in the bill. So what is the relationship here? Copy paste the same thing. It is fine. Amount charged and then the relationship connectors. This is also one time. You have to drag it from the patient to the amount charged. Make sure it doesn't overlap. Okay, so this is how you can adjust it. And then from amount charged, it goes to bill. So one patient can be charged for M number of tests he has undergone. So there can be M number of bills for which he has to pay the amount. This is between billing and the amount charged. So you can also bring it down and make it look straight. Right? So this is how it should look. Now it's very neat. A patient undergoes test. Patient settles the bills. One patient can have M number of bills to settle. One patient undergoes M number of tests. Patient has attributes. Test attributes are defined. Billing attributes are defined. So within billing you will have the bill ID, bill date, patient ID and the bill amount. This is one complete part of a patient test and billing relationship, entity attribute or entity relationship diagram. So what is ER diagram? ER diagram means entity relationship diagram. So if you want to use colors, you can do that. You can go to design. You can choose the type of a color you want. Automatically the color formatting will come. So based on the theme you select, you will have the corresponding variants within that theme. You can choose the variant. So you've selected a slice variant, so you have different variants in it. So you can choose whichever variant you want and you can make it look very colorful. Visio has many such features, so you can try all of these. So this is all decoration part of it, so we're not going to cover much on these, but I've shown you how to do it. All your design related activities for a CHENS diagram or any diagram for that matter, go to design, click on the theme, whichever theme you want, and then look at the variants, however you want to create a variant for it. Most important, create a heading, what this diagram is all about. So this is a CHENS, CHENS, CHENS diagram, or you can say CHENS representation patient workflow in the database, or patient schema. Take a text, drag the diagram number. You can also have split CHENS diagram for different parts of a schema. But when you have a relationship, it's better to have one change diagram. But if you think you want to break your change diagram into multiple entities, then you can also do that. So this is one. So you can tell what which functionality this diagram represents, and then the next set of diagram that you want to define below this. That is also correct. Move up. Keep it at the center. So all these are best practices of a proper modeling and diagramming. How does it look? When they take a printout, this is how it's going to look. Very presentable. Very easy to understand what is what in this. So you will have to do this as a BA. Once this goes to the developer, database developer, they will know what are the tables and what are the attributes or fields to be included in a table. I will show you how to map a change diagram or an ER diagram to an actual database and a table in a SQL server. Save the diagram. Okay, so this is done. Change diagram is done. So now we have completed schema. You know what is a schema? What is a relationship in data model? What is a change diagram? Right. Next, we will learn concepts about data business analyst proficiency document. We'll go through it. Then we will finish the 5 eyes Ishikawa diagram, correlating it, and then the website requirement specification. So further to this, we also have a pending to be completed, which is the state mission diagram. We will finish that. So there are a lot more topics that we have to cover. We'll take a short break and we will come back. Hi all. Welcome back to the business analysis training program. Okay, in the business analysis proficiency assessment document, we have details relating to the BA tasks that you must be thorough even before you start as a business analyst. So here within the BA planning and monitoring, so this is a framework of tasks that we have taken from IIBA Babok guide. So these are the standards. So within planning and monitoring, you must know the business analysis approach, stakeholder engagement, business analysis governance, business analysis information management, and business analysis performance improvements. So we have seen all these details. Elicitation, how do you prepare for elicitation, methods of how you conduct requirement elicitation, and how do you manage the stakeholders, how communication is managed. So we have seen the communication plan for it. Requirements lifecycle management, how do you trace requirements, that is traceability matrix, maintain the requirements, prioritize requirements, assess requirement changes, that is the requirement change management, approve the requirements. So we have seen all the phases involved in a requirement life cycle, how you plan for it, how you elicitate or gather it, and then how do you manage the requirements that you have received. Next, this strategy analysis, in the system analysis phase, we have seen how do you analyze the current state of the system, future state of the system, assess risks, and how do you define the change strategy for the system. Requirement analysis and design definition, what are the different models, how do you verify the requirements, validate, define, and analyze. We have seen all this. And then how do you provide a solution. So this we have seen as the core competencies. We know how to handle all of these core competencies as a business analyst. We've seen how you can implement each one of this, where you have to use your analytical thinking, problem solving, behavioral characteristics, business knowledge, communication skills, etc. So business analysis techniques include acceptance and evaluation. So we have seen the evaluation and acceptance criteria under user story. Backlog management as a part of agile management, agile and scrum management. Balance scorecard, I will show you what it is. Benchmarking, brainstorming, business capability, creating business cases, and then creating the business models. What are business rules? How do you create the concept model or the business process flow? Data dictionary, data flow diagram, data mining is not needed. Data modeling is done. Decision analysis, how do you take a decision based on the as a system and to be system modeling. Document analysis for the existing system. Estimations, which you will do with the project manager. So financial analysis, that is more of project estimation or budgeting. Functional decomposition means how do you break the functions, how do you create functional and non-functional requirement document, how do you create use cases, and how do you break down the system or decompose the system, total system functionality into sub-functionalities or modules. Interface analysis, interviews, item tracking, how to do that. I've shown you the business analyst tracker, so that's what it means. And then mind mapping, this is still pending, we'll see this, it's very simple. Non-functional requirements we have already seen. Observation, prioritization, process modeling, risk management, roles, and then sequence diagrams, stakeholder, personas, creating mind map. Mind map is one topic which has to be completed. State mission diagram, I'll show it to you. SWOT analysis, use cases, user stories. So all these workshops, other details we have seen in detail. We have seen it completely or thoroughly. So we have covered most of the concepts. Some of the concepts are still pending. We will finish all those. A few more topics are there, and then we will move on to tool-based understanding, Excel, SQL Server, Tableau, MS Project, and Pencil. So we'll see how to use these tools after these concepts. So we are done with the business analyst proficiency document. If you have a doubt, what are all the concepts you must know even before you take up a business analyst job or take up an interview, you can go through the BA proficiency document. 5 I's. Okay. What do you mean by 5 I's? It's mainly used to analyze the root cause of a problem statement. Root causes rarely present themselves or are identified immediately. Often we may misidentify deeper symptoms as root causes. Asking why a number of times can be an effective tool to dig deeper into a solution. Helpful in avoiding solutions that lack an understanding of the actual problem. Okay, so asking as many whys. So if there is one problem statement, you will have one answer to it. Don't stop with that. Ask as many whys as possible, right? So we will see an example of how a 5 why is analyzed using Ishikawa diagram. Ishikawa is a person who invented this diagram. In general, it is referred to as a fishbone diagram. So we'll get an understanding of what a fishbone diagram structure is, and then we will move on to creating the fishbone diagram. Okay, in a fishbone diagram, the entire fish body is considered. The head part of the fish and the body part of the fish. The head part of the fish is the effect, and body part of the fish containing bones is referred to as the cause. The cause is again divided into multiple bones of the fish. People, process, equipment, materials, environment, management. So within a fish, a bone can have multiple branches in it. So that's why they're considering the cause of a problem categorized into people, process, equipment, material, environment, or management. These are the main categories in which the problems are defined. So each of these problems can go up to 5 eyes. So a fish, within a fish, a bone can have different branches. There is no limit of how many bones are there. You cannot count. So similar to that, you can have a branches of problems defined. So how is it basically represented? It is represented like this. So within a coffee shop, what is the main reason for a bad coffee? So bad coffee is the head of the fish. That is the effect. So within that, what are all the various problems? So not needed that you have to follow all these categories. If you have only a few categories to capture, you can use that. So here we are using people, procedure, material and equipment. So there are issues with these categories, and that's why a bad coffee is an output. So what is the reason for it? If you see here, the structure of, this is the main bone structure. The main bone structure is nothing but the category 1, or it is a primary cause for the problem. And then you have several other causes that is attached to the main cause. Okay, so this is the basic understanding of a fishbone diagram. Why is it called an Ishikawa diagram? It's called as an Ishikawa. Ishikawa. Ishikawa is the person who invented the fishbone diagram. So you know how a body of a fish is divided, head and the body. So within the body, why bones are divided into different categories of representing a cause for the problem. Now we will move on to create the actual fishbone diagram. We will see the state machine later. Open Visio, blank drawing, click on view, page width, remove the ruler, scroll up, more shapes, it is referred to as a cause and effect diagram in Visio. So generally it's called a Ishikawa diagram or fishbone diagram or cause and effect diagram, because a fish body, the head of the fish is the effect and the body of the fish is the cause. So it's mainly referred to as a cause and effect diagram. What is the cause for the problem and what is the effect of that problem? That's what it means. First, create this part. Okay, it is a bad coffee. What is the effect? So you need to place the fish frame at the end. So make sure you have proper spacing on the top and the bottom. Plan it first and then create the structure within the fish, and then you have to place the fish frame on the structure. So I need proper spacing on the top and the bottom. So first is the effect. I've taken the effect and I would call it bad coffee. So that is the effect of the problem. So why is the coffee bad? For that, I have to add the categories. So all these procedures, process, people, material, environment, equipment, all these are categories within the problem. So I have the categories defined here. My first category is a procedure. The procedure in which the coffee is produced has some issues. That is why the result is a bad coffee. So what is this? It's a procedure category. Next, I have the people category. Okay, for now leave this and finish the first part, the top part of the diagram. So within procedure, what is going wrong that is resulting in bad coffee? That's what you're going to analyze. So you will ask as many questions as possible. So maximum we are targeting 5 questions. That's what is referred to as a 5I. So you will ask 5 different questions to the maximum extent possible, or even beyond 5 questions, but keep a target of 5 questions. So that's referred to as the 5I and cause and effect diagram analysis. So within procedure, 1, too much of water gets added. Because why? Why too much of water is getting added? Because no training. Too many grounds. Why? Wrong size filter has been chosen. Too much coffee liquid has been used. Too much of decoction is used. So these are all procedure based issues that is resulting in a bad coffee. Imagine within a cafe, any cafe. I don't want to use any brand names. So simple cafeteria or a cafe in which a bad coffee is produced and the purchase of coffee is reducing. Though everything is in place, the owner has purchased all the required machines and very good environment, the location, everything is fine, but still people are not buying coffee from them. So the owner decides to approach a quality specialist within his company who will he will tell him, okay, something is wrong with the quality of the product or something is wrong. Sales is really going down on a day-to-day basis. Can you please analyze what it is? So what is the cause? The effect is sales is going down and it's because the bad coffee is bad. So you have to perform the cost for it. So either it can be performed by a process improvement group or a business analyst or a quality analyst. So only these three people will do the analysis, cause and effect analysis. So within process improvement group, you have the Six Sigma, green belt, black belt or lean black belt. Now we will see how to add the within procedures, what are the reasons. So here you have a primary cause. The first level is a primary cause, drag it and drop it. So what is a primary cause? Too much of water is added. Too much of water, no? What did I type? Okay. Too much of water is added. So now if you're using the connectors like this, you will have an issue typing. So the best way is to use a connector. So just to give you an example, what is a primary cause and a secondary cause, I used it. But you can use these connectors as well. So you can click on the pointer tool. Or you can have it as a straight line and you can use a simple text on it. Either ways you can do that. So if you see here, this is a text and this is a connecting line. So that's what we have done. It gives a much better look. You can use a primary cause, but then you cannot have the text above. That's the problem. Okay, next you need to have the main reason why, the secondary reason. A secondary reason, okay, because it's a right angle, it is giving this problem. Click on design and change it to a straight line. When you're doing a fishbone diagram, all your connectors should be straight lines. So it's only a one-time effort to create a text box. Then on, you will just copy paste the text. No training, that is the main reason. And then it's very easy to change the shape and then drag it and drop it on this. Again, adjust it accordingly. Right? Next, you have too many grounds. Everything is ready. Copy. Copy, paste. Move over here. Easiest way to create it instead of struggling with where to place it. Too many grounds. And what is the reason? wrong size filter. You have to just move it a little higher. Next, you have a primary cause. Control V. Stick it over here. If you want to move it one step higher, use your space shift key. What is the reason? Too much coffee liquid. See how easy it is? It is a one-time effort. Once you create one of the primary cause and secondary cause, it's easier. You can just copy paste it. Next, you have to define the arrows. So it's always upward arrows. And here it's a reverse arrow. Depends on where you're placing it, that's it. There's no specific meaning to it. Okay, so now one part is ready. Procedure is ready. Next you have to add for people. People, again you need copy, paste it and fix it properly on your, make sure it is in a straight line with the other diagram. You can leave it somewhere and then you can use your shift key to adjust it accordingly to match to the other adjacent category. Make it look straight with that. Wrong fee. Wrong fee has been collected. So that is another reason. So it is a people-based problem. And why is that? A wrong fee was collected because the computer was not updated with the correct amount to be charged. Right? So, next, why did that happen? Because proper training was not given. See, once you create it once, it's so easy to use. So no training. So you'll have to create all these in a paper and then you have to start creating the diagram looking at the sample you have drawn on your notepad. Next, the top part is done. Bottom part we have material, environment and equipment, out of which we are considering the material and equipment because environment is absolutely fine. The ambience is really good. That's not an issue. So under material, what is the problem? Bad cream. It's outdated. Lids don't fit the cup. So when we are talking about a material, it is about the coffee cup. Bad sugar. Packets were wet. Sugar packets were wet. So these are all the reasons why a bad coffee was prepared and sales has come down. Material, you have to take the category 2. All those you create below the main bone of the fish should be a category 2. The above ones are category 1. So this you can use the same thing. Copy, paste, bring it closer to this. Okay, what is the reason? Bad cream. So how will you get these reasons? You can, if you do not know it upfront, you have to have a customer questionnaire, right? You can create a customer questionnaire. We have already seen how to create a questionnaire for a procurement system. Similarly, you have to create a customer questionnaire for the problem, right? What is their feedback? So for sure, they will give an input about each and every item. So you have to add all these details relating to procedure, people, the material used, equipment, etc. Whichever you want to ask them, they will fill it. Either you can give it as a hard copy, or you can also have it system automated. Some iPads can be present in the center where the customer can select the options and save it. Okay, these kind of customer surveys, it's generally called as a customer survey. When we go to bigger cafe shop or bigger malls, what happens after the shopping, when we come out, they will give you a handout, right? It will be a printout basically asking for customer feedback. So customer feedback is nothing but a survey. So you will collect n number of such surveys and you will come up with a cause why the customers are not liking the product. That's what we are trying to do here. So after finding out from the survey, you will create a CNE, that's a cause and effect diagram like this, and you will have the most important causes the customer has given a feedback as. You know, they may deny that the coffee is bad, they may deny that the coffee is good because they didn't like the coffee because whatever reason. They will tick. You have to, don't ask them to write paragraphs, don't give them a blank. No one has time to write anything. Just give them different 3 or 4 different options where they have to tick. Cream is bad. What is the reason? Because it's outdated. You do not have a shape like this which is downward. So you have to create a connector. Don't worry. Right click and straight connector. And then you need a text. Take a text, paste it somewhere outside. It's called outdated. Type the text and then go to the pointer tool. With connector tool, you will not find the rotate option. Go to the pointer tool on the text box and rotate it. Okay, it is not rotated properly. Place it on that line and rotate it. This seems to be okay. Move to the center. And change the style. So this is how it has to be. Cleverly use the shift and the arrow keys. Okay, this looks much better. Next, if the height is not enough, you can drag it to make it a little lengthier. Okay. Next, you need to have lids don't fit the cup properly. Next, you have bad sugar. Why is the sugar bad? Because the sugar packets are wet. Create a connector straight connector. And then you need a text box, more of a pointer. Pack it wet. Turn it. Move it. Change the line. Done. So we are done with the material causes. Next you have the equipment issues. So in the equipment issues, I'm not going to draw this diagram because I've already shown you different types of placement of these primary causes, secondary causes, categories. So we already have this ready. So here the the main category is equipment. So within that, when you have a straight line or first level description of the problem, it is called as a primary cause. The second level primary cause can be either from left to right or right to left. So left to right is the primary cause 1, right to left that you draw, all these are primary cause 2. However, it is a primary cause except for the direction in which it is drawn. Secondary causes, you have 6 different secondary causes, which means maximum you can go up to 6 secondary causes. If you go beyond that, it will look clumsy. That is the problem. So try to accommodate all your causes within 6 secondary causes, and don't think you can have only one statement. You can have say about 3 to 4 points defined within, see this entire thing, you can have a big line, you can have 3 to 4 points defined within a particular text that you're placing on a secondary cause or a primary cause. A primary cause should be one statement. Secondary cause can have 2 to 3 statements within it. So you can have 6 different types or 6 different why. So coffee not hot enough. Why? Warmer is not working. Why? Servicing was not done. Why? Maintenance fees crossed the time limit. So you have asked 4 whys. Equipment, there is an equipment problem. Yes. Why? Coffee not hot enough. Okay. Why? Because warmer is not working. Why isn't it working? Servicing was not done. Warmer was not serviced. Why? Because the maintenance fees crossed the time limit. The annual maintenance fees paid got elapsed. They didn't renew it. That's why the service was not done. So it is a major failure. It's resulting in a bad coffee and bad sales, right? So this is how you have to link a 5 why analysis. So this is a 5 why analysis. So asking as many whys to get deeper into the problem. So that's what we are seeing here. How do you dig deeper into a situation? So now this is already ready. So I do not want to redo this diagram. Copy this, paste it here. Okay, some of the lines have not been copied. Or you can try doing this part. I'll show you how to place the fish frame, being cautious with how you place it on this. So once you have all the, and now leave your fish frame, adjust it properly. It should not overlap on any of the categories. Okay. So now the fish frame is ready. Click on view, remove the page breaks. We don't need any page breaks for this. This is a very nice fish diagram. So make it smaller and see if it is all aligned properly. Yeah, it looks good. except for this should be one step higher. It's almost one step higher. Okay. So I will leave this part of the diagram blank. I want you to practice this. Don't copy paste it. Try doing this, adding the connectors, because the challenge here is how do you add the connector, how you align the connectors, and how do you add the text to the connector. So once you do it properly, once it looks presentable, only then add the fish frame to it. All the details that you add should sit within the fish frame. You shouldn't have any details that's kind of moving, overlapping the edges, borders of the fish frame. It's called a fish frame. It should not overlap. It should exactly match, and it should actually look like a fish and the bone. So that is the best part of this diagram. So it is much easier. We have all these shapes already defined, the connectors and the text. So you have to just copy those and make changes to it accordingly based on this sample diagram given to you. I'll name it as a cause and effect diagram. Done. So we are done with 5i and fishbone diagram with analysis, what it actually means. So this is all completed. Next we have to get into website requirement specification. When you are creating a website, how do you create a specification for a website development? We will quickly finish that and we will get back to, this will not take a long time because we have already covered other types of documents. So it is almost the same, but this is for a website. So you know what is the difference between a standalone application and a website. Okay. So while you are developing a website, if you work as a business analyst, because most of the projects are website projects these days, so we do not have any of the standalone applications. At least you have 3-tier applications in existence, but 2-tier or just a plain standalone application is not getting developed these days. It's all web-based developments. Web specific requirement specification, website requirement specification. Enter the project name. So this is a header. So enter the project name here. Over here, created by whom and when was this created. This requirement specification is used to record the user requirements for a website. So what is the background? Give a brief description about why this website is needed. Example use case. See, you are just defining the website requirement use case, website requirement specification, but in that you are using a use case model. So you can create this use case. This is a very nice use case that describes what the website should do. So here you have the online purchasing that is done by the website visitor, and then what happens within the actual process, the checklist, create PDF from the checklist, apply PDF functionality to sections. So this can differ. Each and every website will have a specific use case. So we have already seen how to create different types of use cases and how to write use case scenario. So this is an example. You can go through this. Created using Microsoft Visio. So they have used Visio to create this. You can either use Visio or you can use Visual Paradigm. So here the main system is a PDF generator. That's what they're trying to describe, how a PDF generator is going to be used. Next, what's the visitor interaction? How the visitor to the website is going to interact. What is the requirement? You'll have the requirement number. description and comments. You can also have FR. FR is the requirement number. So it depends how you want to number your functional requirement. I generally have it as FR01, and then within the space, within the square braces, I'll have the topic number. So it is going to be FR01 space within square braces number 1. So it refers to first topic in the document. Next, you will have information about editing, updates and administration activities. So you have to enter all those details here. Sitemap and navigation. So within your website, what are the various navigations that are there? What do you mean by navigation? When you open a website, on the left hand side or the right hand side, you will find different options to navigate. For example, when you open Yahoo web page, on the top you have navigation bars to check your mails or go through some Yahoo related news, etc. On the within the document, you will have various other links within the web page. It's called as a web page. So within the web page, you will have different menu items. Sometimes you can have a menu bar on the top. When you hover your mouse on the menu bar, automatically a drop down will come up, and then within that drop down there can be sub menu items. You can select whatever you want. So that is referred to as navigation. How do you allow the user to navigate to different pages within a website? So in an application it is referred to as a form. In a website it is referred to as a page, web page. Okay, so what are the different pages available in your website and how you're going to allow the user to navigate? That information you'll have here. Content management, what's going to be the content within your website? What is the information that you're going to put within your website? So that's content. Tracking, website statistics, which user is using which website, which web page maximum. So how many users are using only first 2 pages? How many users are crossing the 3rd and the 4th page? How many users are completing the sales or viewing the product and they are moving to the last web page? So all these are captured under tracking website statistics. Next is the search engine optimization or SEO. So when you perform a search, right, the result that you get must be much faster, and then your website's SEO, search engine optimization, means the popularity that your website is going to get. So there is a way in which when a user types a particular topic, the website list of websites will get listed in Google or any search engine. So if you want your website to appear in the first page or on the first top position within that search engine's the search activity, then there is a particular way to do that. So we all know how that is done. It is referred to as search engine optimization, and the development team can help you with this. Either the development team can do it themselves, or there are other external third-party agencies that can take care of having some of the keywords linked to your website, and when the user types that on any of the search engines, right, Bing or Google or any search engine, automatically your website should appear on the top. So that's how we have very good brands these days, right? Branded online purchasing websites. So when you type purchase online, automatically the most best brand websites are listed in the first page. How is that happening? Because search engine optimization is done externally. Editor, interface, web content management system. So these are all advanced concepts. You can check with the development team of what you want to fill. Accessibility, how your website is going to be accessed, and various styles and designs that you would like to use. Right, so accessibility includes different operating systems and different browsers in the operating systems on which the website can be opened. So you have to act as a user and assume all the possible browsers that the user can use to view the website. And also nowadays people are, we have users working on iPads and mobiles, iPhones, on which they view the website. So you'll have to check if there is no mobile app, then accessibility on mobile phones of your website should also be possible. So resolution should also be adjusted accordingly. If the website navigation on the mobile gets difficult, or if the website or a web page view is much smaller on a mobile phone, and some part of the details within the web page is not shown because of the sizing issue, So those are all screen resolution issues which should be solved by the developer. Developer should take care of it, and you should work with the developer on all those aspects. Styling and design, that will be taken care by the developer, but still you, while creating a wireframe, you will also get the details about the styles and the designs that you have to use on the website to make it more attractive and decorative. Security aspects, very, very important. If there is an online purchase that your website allows, you should have the SSL kind of security features, wherein there should be a payment gateway through which the customer pays the amount. So their details, their card details, CVV numbers, those are all not visible to the hackers, right? So there should also be a good security to your website. So as I told you, there are encryptions and algorithms to be used for that you can follow up with your network security team, as well as the development team that works on the user authentication credentials and the security norms. Hosting, where will you host your website? A website should be hosted on a server. So which server, where is it going to be located? Are you sharing the server space physically where it is present, etc.? You have to work with the hardware team and the development team for that. Maintenance and support, the maintenance and support team, development team, all together will work on the maintenance and support activities for the website. So you have to capture all those details. So for a website development, there are so many teams that are involved. So you have to get inputs from each of the team. Within development team, for the designing of the front end, there could be a UX specialist. They are called as user experience specialists. So they will primarily work on designing the user experience, how the user experience should be. They will create the front end using HTML5 or other user UX front end languages. So they will create a view of it. So not just the wireframe. At times you have to also approach, most of the times UX team decides on the front end, the UI, how it is, but you will participate in all those discussions. You will also be there, you will contribute your opinion, because you're the one, as a business analyst, you would have collected the requirements, correct? So then you put forth to the other teams who are going to work on it. If there are going to be any graphics involved in the website, any flash based, Adobe flash based videos, or what do you call the graphic animation part of it on your website, that will be taken care by the graphics team in your company. So you must know different teams who are involved in developing the website. So other requirements you will capture here. Any exclusions, considerations and assumptions you have to capture. And all other appendix and other details remain the same. So here we have given only the extra details that you will capture for a website requirement specification. But other than that, normal software development process will be followed even for website development practices. So here is another example for a website. What are all the various details you have to follow? So how is a website accessed? A website will have a URL. It's called Unified Resource Locator, Unique Resource Locator. So you should have the URL, and then HTTP refers to Hypertext Transfer Protocol. So most of the time we work on HTTPS. We don't work on HTTP. HTTPS stands for Hypertext Transfer Protocol Secured. Okay. And this part of the server is referred to as the IP address. So IP address of a server or a machine. These days you do not have an option to view the IP address, because it's much easier for the hackers to hack the server and get all the details from it. So the IP address will be masked, right? It will be masked, and you will have a server name. Index.aspx refers to the index is an home page or the first page of your website. ASPX is the technology. ASPX stands for ASP.NET. Most of the web development technologies are ASP.NET, ASP, JSP, that is a Java server page, PHP, HTML, HTML5 is used, and CSS, Cascade Style Sheet, is also used. There are many other technologies that are used for web development. You have to check on those, okay? And then you have a website called w3schools.com. So it is a website solution, is hosted on a server. The server has a public domain name and a public domain space which is purchased. So what is a server space? A server space is in-premises hosted server. So if the server is hosted in your company or owned by the company, it is called the in-premise hosted server. The server is hosted in your company's campus. Whereas if you buy a server space and a public domain name, which is unique to host the website, it becomes a cloud-based, right? So because you're sharing the server space with someone else. So you have to be very cautious with the security norms when you buy a server space and when you use it. www stands for World Wide Web. So this is a sample website that I've given you for you to go through. Cloud-based hosting. What are the different cloud-based hosting we have? Amazon, Microsoft Azure. So the Amazon and Microsoft are the major cloud-based service providers in the market these days. Amazon has several cloud-based hosting, website space, and a complete AWS, wherein you can install different applications, right? Other than that, you have the Microsoft Azure. So in Microsoft Azure, what are the various applications that can be installed, and what is the infrastructural change that you have to do, system-based changes that you have to do. So all these will be taken care by the development team, but for you, you should have an understanding about these terminologies, because you have to understand what are these. Only then you can work on a web development project. Cloud-based development, number of systems on which the software gets installed is reduced, and instance of a software access is much improved. So that is the main preference of cloud-based development. Okay, so we have covered website development. Next we have to get into technical specification document. I'll show it you later. We'll finish the database part. So we have a lot, we cannot finish this now. We will complete the state machine diagram. Then we will see how time permits for a entity relationship diagram. So here's a state machine diagram. So we have already seen a state transition diagram while we were going through the project. Get it to page width. You need a state machine. Go to software, UML state machine. This is a UML standard. So here we will see how a sales activity or a sales functionality is represented using a state machine diagram. We will first understand what this diagram is all about, then we will try to create this diagram. First, a sale starts. Then you have to add item. Open for the add items, which are the different states in which the mission goes through. So mission is nothing but your software, so or the system. Then complete sale. It is ready for shipping. Begin shipping. Within the shipping you have begin shipped, and then wait for ship. The shipping is current. Waiting for back orders. So back orders to arrive. Again the shipping process is continued. So when the shipping is completed, it is in the shipped state. Payment is cleared, it is closed, archived, and end of the process. So what are the different states in this complete procedure? Here we have start the sale, add the item, complete the sale. So once the sale process is completed, we are not targeting about how CO is created, SO is created, how sales orders are processed. We assume that it is all done, the sales order is processed, it is ready for shipping. Then begin shipping. So within shipping, begin ship, what are the different states within shipping? So begin shipping, within shipping we have begin shipped and waiting for back orders. So once the back orders arrive, again begin shipping is started. Then the process continues. So within shipping we have recurring process that keeps going on. Then the shipping is completed, it moves to shipped state, and then it's closed. Payment is cleared, it's closed, archive, and close the complete process. So there are different states in which the entire system is moving through. So the state machine diagram mainly describes the states in which the mission means your software, right? So this can also be used by a mechanical engineer, it can be used by a manufacturing engineer. So different states in which the mission moves through, or whichever system you are using, that is the main logic. So what are the different shapes here? We have the state shape that represents one possible state for the system. Initial state, that is the start of it. Final state is the end. Choice, if there are any choices to be made in between, or a decision. It is same as decision. And note, you already know it's an annotation wherever you want to represent a note. Other than that, we have three different items defined here, the shapes. Composite state, a state that has substates. Drag on to the page and add the states inside the shape. So what does this mean? A state that has substates, right? So how is a composite state defined? Here is a composite state. So this is just a sample. So if you have sub-processes to be substates, here you will not refer it as a process, it is a state. If there are substates to be defined, then you have to use the composite state. Again, submission state, a composite state whose internal details are not visible. If it is visible, it is a composite state. Or if it is a composite state whose internal details should not be visible, then you have to use a substate. In a submission state, you have the withdrawal and deposit details which are not visible. So you have this I sign, it's a spectacle sign, which means it is not visible. You will not display any money related withdrawal or deposit as a part of your submission state. Other than that, we also have a state with internal behavior. So each and every substate defined within the main state, that is the internal states that are defined within a state, can have entry, do and exit, right? So these are submodules within the main module. So for each of the submodule within the main module, what is the entry? Means what is the start, what you have to do, and what is the exit. So that's how you can represent different substates within the main state of a process. We will see how to create this diagram. You have to use both state transition and state machine. So decide where you want to use which type of a diagram. Mainly for analysis model, you will use state transition diagram, that is a simple process flow, right, which we have already seen. I think I've shown you a state transition diagram. Yeah, this is covered for you. So this is how we created a simple state transition diagram for an online purchase processing. Next, we had an example that we had to look for the online purchase order. So each and every state, which is similar to your FAFL concept, the states through which the machine is moving. So here you have the waiting state, empty cart, then add item, clear the cart, etc. So these are direct system states, but this is an in detail description of each and every state that the machine is moving through. That this is at a high level, this is at a granular level. That is the main difference. Okay, the first thing you have to do is start initial, reduce the size, fill it in black. Next, start sale. So you need an oval here. You don't have it here, so you have to use a basic, yeah, it's all flowchart, basic flowchart shapes. So we need a process. You can use this. You can also use basic shapes if you're not finding it. I need an oval rectangle. What shape is this? Okay, so you can use a round corner rectangle for it. Give proper spacing. Open for item ads. Forget all S1, S2. You can leave it. These are different states through which the item, the machine is traversing. You can forget all those. So keep it as simple as possible. It's another state. It's ready for shipping. And then you have to start a new state. Drag the state. Make it bigger as needed. And then name the state. It is called in shipping. So within the state, again, you have an initial state. Keep it as small as possible. Drag it inside. And then you have a process here that's called begin ship. Begin to ship. You have another process called waiting for back orders. And then the outer states. This is a shipped state. Then you have a closed state. Then you have a stop. Make sure the start and stop are of same size. Okay, now it is done. You have to create the connectors. So from here, you have to add item. You have to click out. Okay, be a little careful when you do this because it can get clumsy. Then you and something like this, and then there is a transit here. Shipping is completed. It moves here, and then from here to this, here to this. That's it. The connectors are done. Then start defining. So it is a start sale. So if you are representing it as within two braces, it means it is a function that the developer has to build. Either you can do that or you can leave it like this. Okay, there is a problem here because the above line is not proper. So if it's getting tougher to manage those lines, you can just use a text box. So learn all the techniques where you can use which type of a shape. That will surely help you when you create the diagram. Use these lines to reduce the sizing. Okay, then over here you can say add item. So this will look correct, right? So next, you also need this is a complete sale. So you can just refer it to as complete. This is begin shipping. The connectors and the way you represent is up to you, how you want to do it. There's no hard and fast rule of how it has to be done. Shipping is current, means it's ongoing. Spacing is an issue, so drag this. Automatically it will get adjusted. Back order arrives. This is shipping completed. It is not correct. Drag it and drag the yellow square. This is payment cleared. Then you have the closure. If you want to remove this and have only one connector, this is also fine. You say start the sale and then open for add item, because already we have a state that describes that it's open for add item. So again, you don't have to specify explicitly that you have to add an item here. So according to me, this is also fine. If you want to have another loop here, which I've already told you, a curved line loop, which you can look at the state transition diagram and you can create a curved line loop to add item. So now this is complete. I have to give a name and a number to it. See, I placed it in the wrong position. That's the problem. Place it correctly within the document, and then if you're copying pasting also it's okay, but keep it correctly. So here size is differing, so take one by one. Don't keep typing this 1, 2, 3, etc. Keep it standard in a document and have it ready for you to copy paste it wherever needed. Make use of the copy paste in Visio, the best practice. Wherever you want, please try doing that. It will save a lot of time. Otherwise, you will find creating diagram in Visio very difficult if you're not practicing the copy paste activity. Create it once, don't keep doing the activity again and again. adjust the sizing and release it. Now this is all ready. So if you want to add any internal state or a composite state, you can add it below this. Click on view. This is a basic, simple state machine diagram. You can make it complex if you want to have any internal systems or composite state with visibility, without visibility. I've told you how you can create it. You can use those. Click on File, Save, Browse. This is a state machine diagram. There's a difference. If you prefer to use only a state transition diagram, you can do that. But if you think you want to represent a sub-state internal activities, composite state or a plain state, you have to use the state machine diagram. Okay. So we didn't. Okay, here is another example which is loaded for you to identify what are entities. So within a car, power steering, window, wheel, front, back door, music system. So these are all examples of entities. Laptop, your screen, screen guard, mouse, inbuilt keyboard, all these are different entities. RAM, camera, microphones. This is how you identify an entity, and relationship I've already told you what is it. And then Ishikawa, we have already seen it. This is another example I wanted to give you how you can identify entities. So all the details as decided, planned for today have been covered. State machine diagram, use case specification, RTM, schema, relationship and data model for Chen's diagram. How do you create Chen's diagram? What is a business analysis proficiency document? Go through it. Make sure you learn all those concepts. So everything has been covered for you all. Learn those. The 5 eyes, Ishikawa, fishbone diagram. How do you correlate 5i with fishbone analysis or cause and effect diagram? Website requirement specification. Okay, so next session we will cover the technical specification document, then database related concepts, and we will move on to using the tools. Open to questions. You can also post the questions on the blog. All these diagrams have already been posted there on the blog. You can please download and practice it. I'll add some assignment questions relating to the topics we have discussed yesterday and today. Please practice those as well. We'll have a good week ahead. Speak to you next Saturday. Thank you all. Bye.